Hello again, everyone. This is Mr. V. Hill, and today we're going to be talking about the quadratic formula. And the quadratic formula is just, well, how you solve a quadratic equation. It basically just says that if we have an equation of this form, a times x squared plus b times x plus c equals 0, where a, b, and c are just numbers, then the solutions to the equation are given by this formula. X equals negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. So if you have an equation like this, just figure out what a, b, and c are, plug them into this formula, and then, well, just got to simplify. And that's basically that. Yeah. One thing about this here, though, is this inside the radical, the b squared minus 4ac, that is called the discriminant. Okay, so this value, b squared minus 4ac, that basically just tells you what kind of solutions you have. So if the discriminant b squared minus 4ac happens to be greater than 0, meaning positive, then we're going to have two real solutions. And by real, I don't mean other solutions might be fake, but I'm saying these will be real numbers, meaning integers, fractions of integers, and irrational numbers like weird square roots and those sort of things, the things that you find on the real number line. Because if b squared minus 4ac is positive, you take the square root of that thing, well, you're going to have an actual real number, and you have the positive and negative versions of those. That's where we get the two solutions. If b squared minus 4ac happens to equal 0, then we have one real solution. The reason being, well, if what's inside here is 0, the square root of 0 is 0. And adding 0 and subtracting 0 from something are the exact same thing. So you don't get two different solutions, you just get the one. And now, if b squared minus 4ac happens to be less than 0, meaning negative, then we have no real solutions. There are solutions, they just happen to not be what we call real numbers. Because in the real number system, you can't take the square root of a negative number. And that's all that that means right there. So let's see how this works with an example. And call it example 1. Let's suppose we got x squared minus 5x plus 6 equals 0. Now, in order to apply the quadratic formula, we do need the equation in this form where one side is equal to 0. Very, very important. If that's not the case, well, we just subtract what's over there and make it equal to 0. No big deal. Now, just identify what a, b, and c are. A is the coefficient of x squared. So in this case, a is 1. B is the coefficient of x. Now, be careful here because this is subtracting 5x, which is the same thing as adding negative 5x. So here, b is equal to negative 5. And then c is just the constant term here, which is 6. So we just plug these values into the quadratic formula, and that'll give us these solutions. So x now has to be equal to the negative of b. So be careful here when b is negative. This is the negative of negative 5 plus or minus the square root of b squared. So it's negative 5 squared minus 4 times a, which is 1, times c, which is 6. And that whole thing gets divided by 2 times a, which is 1. And that's it. Those are the solutions. Negative of negative 5 plus this square root divided by 2, and negative of negative 5 minus this square root divided by 2. So now all we got to do is simplify a little bit. So here, x now is equal to, the negative of negative 5 is just 5, plus or minus square root of negative 5 squared is 25, minus 4 times 1 times 6 is 24, all divided by 2 times 1, which is 2. No big deal. 25 minus 24 is, of course, just 1. So we got 5 plus or minus the square root of 1, all divided by 2. But we know what the square root of 1 is. That's just 1. So x is 5 plus or minus 1 divided by 2. So what this really means now is we have two different solutions. One using plus and one using minus. So x is equal to 5 plus 1 divided by 2, or x is equal to 5 minus 1 divided by 2. Do a little bit of arithmetic here. 5 plus 1 is 6 divided by 2. So here x is equal to 3. Over here, 5 minus 1 is 4. Divide that by 2, and we get 2. So there's our solutions, 3 and 2. So the solution set consists of those two values. Now, of course, we can check our solutions, and we should always do that. Here, since these are nice numbers, it's easy to just plug them right into the original equation and see if we get a true statement out. So, plug in the 3 here. 3 squared minus 5 times 3 plus 6. Is that actually equal to 0? 3 squared is 9. Minus 15 is negative 6 plus 6. Yep, that works. But then let's check the other one. 2 squared minus 5 times 2 plus 6. We ask ourselves, is that actually equal to 0? 2 squared is 4. Minus 10 is negative 6 plus 6. Yep, that's also 0. So those are our two solutions. Those work. There's our solution set. Pretty simple. Let's try one more example. Let's try this one. 3x squared minus 6x plus 2 equals 0. Again, all we got to do really is just identify what a, b, and c are. A here is 3. B is, be careful here, negative 6. And C is 2. So again, all we got to do is plug those into the quadratic formula. So the solutions to this equation are given by x equals negative b. So be careful because it's very easy to lose a negative sign there, especially when b is negative. Plus or minus the square root of b squared minus 4 times a, which is 3, times c, which is 2. All of that divided by 2 times a, which is 3. That's that. Now all we got to do is simplify. That's why I did a whole lot of practice on simplifying radical expressions. So here, x now is equal to the negative of negative 6, which is 6, plus or minus, excuse me, the square root of negative 6 squared is 36. 4 times 3 times 2, that's 24. All divided by 6. Of course, 36 minus 24 is 12. So we got 6 plus or minus the square root of 12 all over 6. But 12 has a perfect square factor of 4 inside of it. So this is 6 plus or minus the square root of 4 is just going to be 2, and what's left is going to be the square root of 3 inside there. All divided by 6. And we can split up this fraction just by distributing the dividing by 6. So now x is equal to, well, 6 divided by 6 is 1, plus or minus 2 root 3 over 6. We can simplify the 2 and the 6 here. as root 3 over 3. So there are two solutions, one plus root 3 over 3 and one minus root 3 over 3. Now we could plug these back into the original equation. It's going to get a bit cumbersome. So another thing we can do is just check with a calculator, which we've kind of already seen before. Just get the approximate values here. Let's see here. So we've got 1 plus the square root of 3 divided by 3. 1.577. So here x is approximately 1.577. Now if we do a minus version, 1 minus the square root of 3 divided by 3. X is going to be approximately 0.423. And then we just look at the graph here. Y equals, we'll graph 3 times x squared minus 6x plus 2. Graph that. And there we see our two x-intercepts. Those are the solutions to the equation, because that's when the y equals 0. And so calculate the zeros here. Let's see here, where is my cursor? There it is. Now we're left of the leftmost one. Enter. Make sure we're right of it. And there's our 0.427. Solution. Let's calculate the other 0. And sure enough, yeah, 1.577. So those are our two solutions. So our solution set consists of, and you can write these as just 1 plus or minus the square root of 3 over 3. So we have the solution 1 plus root 3 over 3 and the solution 1 minus root 3 over 3. That's basically it for the quadratic formula. It's just a matter of plugging in numbers and then simplifying. And yeah, pretty boring. So the more interesting part of all of this is why the quadratic formula works. And this really comes down to completing the square. That's all it is. So we just take this equation and complete the square on it, just like we did with the equations when a, b, and c were actually numbers. But let's do this in general. So first off, when we're completing the square, having an a value here or a coefficient of x squared that isn't 1, well, that kind of messes things up a little bit. But that's easy to fix. We just divide both sides by a. No problem. We distribute that dividing by a, and we end up turning the equation to this. X squared plus b over a times x plus c over a is equal to 0, because 0 divided by a is just 0. Now, when we're completing the square, the thing that we wanted for the constant term, well, we got that by taking this coefficient of x, which is b over a. We'll take half of that thing and then square it. So first up, well, obviously, so half of b over a squared is not c over a. So let's just get rid of the c over a. So we'll add negative c over a to both sides, because that's just going to cancel this thing out, and that'll go away. No problem. So we have x squared plus b over a times x, I'm going to leave some space here, is equal to negative c over a. Now we just need to complete the square. So we take half of the coefficient of x, which is b over a. So half of that thing would be b over 2a. But we want to add on the square of that. And we'll have to add that on to both sides of the equation. No problem. And the nice thing here now is that this is a perfect square trinomial. Whenever you have this, that the constant term is the square of half of the coefficient of x, well, that thing factors down. And so what we have here is really x plus b over 2a squared on the left-hand side. And if you really want to verify this, just multiply this out and you'll see that that's exactly what you get. Now, just for purposes of making it look more like the formulation of the quadratic formula that we just saw, I'm just going to apply the commutative property here. So this is b over 2a squared, and adding negative c over a or minus c over a. Now, the x is only showing up in this one spot. Up here we have problems because we had x over here in the x squared, and we also had x right here in bx, and these are not like terms, we can't combine them, but now the x only appears here. So now we can start undoing what's being done to x. And if you really want to think about this and understand the whole process, this first little bit right here is really all just completing the square. Put a little note here. This whole bit is completing the square. Now that we've done that, now we can start solving, meaning undoing what's being done to x. But of course we have to undo them in reverse order, so the first thing we got to get rid of is the squaring. So we do that by taking the positive and negative square root of both sides of the equation. That's going to cancel the squaring, and so we're left with x plus b over 2a is equal to plus or minus the square root of b over 2a squared minus c over a. Next, we just undo this adding of b over 2a by subtracting b over 2a or adding negative b over 2a to both sides. Leaving us with x equals, now I'm going to write the negative b over 2a first. Then we have plus or minus this big square root. B over 2a squared minus c over a. And really, technically, this could be the quadratic formula as well. We've got x all by itself. Here are the two solutions. This number plus the square root, and this number minus the square root. Notice here also, this term right here, the negative b over 2a, that's the line of symmetry. And the x-intercepts of the line of symmetry of the corresponding function, of course, are going to be equidistant from the line of symmetry on both sides. Plus this distance to the right, or subtract this distance to get it to the left. So really, this could be the quadratic formula. So this part of the process here was just solving. Now what we need to do is just simplify a little bit to make it look like the quadratic formula as it was written in the first place, even though this is just as good, really. So let's take this thing. X equals negative b over 2a plus or minus the square root of, let's first distribute this squaring into this fraction. Remember, everything in here is either multiplication or division, so the exponent will distribute over the multiplication and the division. So we're going to have b squared over 4a squared. Then we have minus the c over a. Next thing, we can do this subtraction as long as we have a common denominator here. So in order to get a common denominator, I'm just going to multiply the c over a by 1, but I'm going to write it as 4a over 4a. Because, of course, a times 4a would be 4a squared. Same thing as what we have right there in that denominator. So now x is equal to negative b over 2a plus or minus the square root of b squared over 4a squared minus 4 times a times c all over 4a squared. Now we've got a common denominator, so we can do this subtraction here. X is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 4a squared. Now we see the discriminant showing up again. Now we've got the square root of this quotient. We can therefore distribute the square root to both the numerator and the denominator. And so we have x is equal to negative b over 2a plus or minus, the numerator is going to be the square root of b squared minus 4ac over the square root of 4a squared. Oh, but great, the square root of 4a squared, and this is a product, so we can distribute the square root to both the 4 and the a squared. So now x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And again, now we notice that we have a common denominator here, so let's just put it all as one fraction. X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And, well, there we go. There's the quadratic formula. So all of this stuff is just simplifying kind of in a way, even though technically, I mean, we could distribute this division of 2a to both of those. But either way, notice here we see line of symmetry plus or minus the same value. So to the right and to the left. Plus moves us to the right from the line of symmetry. The minus moves us to the left of the line of symmetry. So this is really just kind of simplifying the last little bit. And if you chunk it out like that, it's going to be a little bit easier to remember how this all goes. Because, well, you're going to have to do this on your own. So sometime between now and the end of the year, I'm going to just say, hey, everybody pull out a piece of paper and derive the quadratic formula. And you're going to have to do this. Okay? Get to studying.